Okay, so today is the third video. This is the first part of the Chapter 1 review. I'm going to do this video a little bit different because since all of this should be review, I'm just going to walk through the worked out solutions already. So at some point you might want to stop, pause the video, copy down the work, and then go back and follow along. All right, so we're going to talk about solving equations in Chapter 1. We're going to look at absolute value, literal equations, quadratic equations, rational equations, and then radical equations. All right, so let's go ahead and begin and remind ourselves, how do we go about solving absolute value equations? So here's our little reminder of our steps to solve those absolute values. We're going to isolate the absolute value. From there, we set up our two equations by dropping the absolute value sign, solving both equations, and as always, checking our solutions. So let's go ahead and kind of walk through this example here. So what we should notice is, here is our absolute value. We need to isolate this guy before we can do anything else. So we subtract 4, we divide both sides by 2, and now we've completed step 1, okay? Now remember, the absolute value, this is like being in prison, okay? We don't want to touch what's inside. We keep that exactly as it is, but absolute value is representing a distance from 0. So this x minus 5, it can equal 3, just like this, or it can equal -3. So here's step 2 where we're setting up our two equations. Notice the absolute value bars are gone. We can hopefully quickly solve each of these equations, and we get our two answers of x equals 8 and x equals 2. But we want to verify that these truly are the answers by going through that fourth step. And I quickly showed that over here. Sometimes you might be able to do this in your head. Sometimes it might take a little bit more work, but you do need to somehow, some way, check your work to make sure that both of those answers work, providing you with a true statement in the end. Okay, so you can kind of take a look there, and we end up with two true statements. All right, when x equals 8 and when x equals 2, the left side does in fact equal the right side. So we can go ahead and conclude that these are our final answers. The next example deals with literal equations. Literal equations are essentially formulas, and you're solving for a particular variable. So in this case, we're going to solve for t. So what we need to identify is, where is t at? So we see that t is in the denominator. So before we can even really begin to get t all by itself, we need t out of the denominator. So we're going to multiply both sides by this entire thing, okay? So multiply both sides by 1 plus RT, and what we should notice is, now on the right side, these guys will cancel, okay? So now that those guys cancel, we're down to this over here. At the same time, I distributed the p to both of these terms inside, okay? So now we should notice where t is. I've highlighted that. We need to get that all by itself. So the first move is to get this p over to the other side, okay? And now we have r times t times p. All we have to do is divide by rp, or pr, and we get our final answer where t is fully isolated. The next types of equations we're going to solve are quadratics. We spent a lot of time last year solving quadratics, and hopefully you remember the first step is we always want to try to factor first. That's the most efficient method, okay? But we'll go through all of the methods. So let's go ahead and zoom in on this first one, all right? Again, we try to factor first. Since my a value is not 1, we're going to use our product sum splitting the middle. I need two numbers whose the a times b value, so -72, and that sum is 1. So I get 9 and -8. So we're going to split that middle term up, and then we're going to factor by grouping, taking the GCF out of the first group, the GCF out of the second group, and we end up with our factors of 2x plus 3 times 3x minus 4, setting each of those equal to 0 because now we have an equation. We get our two answers of x equals -3/2 and x equals 4/3. Another way to solve square or quadratic functions is using the square root method. We would use the square root method when we have our variable being squared and no variable anywhere else in the equation, okay? So our goal is kind of similar to absolute value equations. We want to isolate the quantity that's being squared, okay? So we're gonna subtract 18 first, and then we have to divide by this 2. So we're here. Now, how do we undo this square? Well, hopefully you remember, we have to take the square root of both sides. Now, a key that we also have to remember is when we do take the square root of both sides of an equation, what do we have to remember? We have to remember this plus or minus, okay? So we take the square root of both sides of the equation, and we're left with x plus 4 equals plus or minus the square root of -9. And hopefully you remember the square root of -9, because it's the square root of a negative, we have an imaginary number, and the square root of 9 is 3, so we have 3i. All I did was I brought this 4 over to the other side, subtracting 4, and we get our two answers here. The next type is to solve by quadratic formula. So here's a good reminder if you didn't remember what the quadratic formula is, right? Remember, it's that x equals -b plus or minus square root b squared minus 4ac all over 2a. I can't believe I just sang a little bit on a video, but there you have it. All right, so just a quick reminder. But remember, our first goal always is to see if we can actually factor this quadratic. All right, so I would use the product sum splitting the middle, product of 4 times -1, so product of -4. Sum is also -4. I can't come up with any numbers. So since I can't come up with anything, I revert to the quadratic formula. I do this. It's not a very efficient method to solve quadratics, so this is why we always try to factor first. So plugging everything into the quadratic formula, you can see, be careful, watch your signs, okay? And then we have to remember to clean up. So we get the square root of 34 within that quadratic formula. We always want to simplify that radical first before completely simplifying our answer. So now I take a look at these three terms here to see if they have any factor in common, and they all have a 4. So now I can pull a 4 out of every term, and this is where we get our final answer from. The last method to solve quadratic equations is using the completing the square method. Now here's my rule of thumb. I only use completing the square when our a value is 1 and our b value is even. Otherwise, it's not very efficient. It can cause more issues than not, okay? So I take a look. I would try to factor this. Two numbers whose product is -5, but whose sum is 8. We can't think of anything, all right? So I notice my a value here is 1. My b value is even, so completing the square is not a bad option. The first step is to throw this constant over to the other side. Okay, at the same time, when I rewrite the next line, I'm going to leave a blank on both sides. This is an equation. We have to keep everything balanced. All right, so now I have to complete the square here. So if you remember, we take this middle term, that b term, we divide it by 2, and we square it. So that's how we get this value here. So I took 8, I divided it by 2, got 4, and I squared it, and I got 16. Now, whatever goes on the left side has to go on the right side. We have to keep everything balanced, okay? So now our goal is to factor this left side, and it should be a perfect square, all right? Completing the square. And what we notice is I'm looking for two numbers whose product is 16, whose sum is 8, and I get x plus 4 times x plus 4, and another way we write that is x plus 4 quantity squared. Cleaning up that right side, we get 21, and now this becomes a square root method problem. So since I'm isolated, I can take the square root of both sides, okay? And when we take the square root of both sides, do not forget that plus or minus right there. And then finally, we have to get that plus 4 over to the other side, and we get our final answer here. This next example, we should notice that it's not a quadratic, right? It is a cubic function, a degree 3, but we can still solve this by factoring, okay? So after it's set equal to 0, we look to see, well, what factor can we take out? And we should notice that we can pull a 2x out of both of those terms, and we're left with an x squared minus 4. Hopefully you recognize that this isn't fully factored. This is a difference of squares, so we can factor that further. So we get 2x times x plus 2 times x minus 2 equals 0. And now we're fully factored. We set each of those factors equal to 0, and we get 3 answers. What I want you to notice with these last examples here is pay attention to our degree. That's how many answers, solutions we should have. So we have a degree 3, we have 1, 2, 3 answers, so it works out perfectly. Moving on to rational equations. So rational equations, remember, it's just fractions. We're dealing with fractions. You're going to hear me say a lot, we want to kill the denominators. Okay, whenever we're dealing with equations and there are fractions, we want to kill the denominators. So how do we do that? Well, if we look at our quick refresher here, similarly to the previous video when we're adding and subtracting fractions, we still want to factor all denominators. All right, we still want to determine the least common denominator, the same denominator that they all have. But this time, we're going to multiply every term by that common denominator, okay? After we do that, our denominators will be killed, all right? And then we can go ahead and solve and check our answers, okay? So let's look closely at this example here. I'm going to zoom in, all right? The first thing I want to do is I want to factor all of our denominators, and we should notice these are actually all factored nicely for us. So then I go to what our LCD is. I'm going to kind of block this part off. All right, so I make a note, and since we're all factored, I go through the first factor in my first denominator, x minus 3, and I write that because I don't have anything yet. I would list all of the factors in my denominator here, but that's the only one. Then I go to the next denominator, x plus 4. That is a new factor. I didn't have it written down, so I add that. And then I go to the next denominator, and I have an x minus 3. Well, I already have an x minus 3 written down, so I don't need to write it down. It's a repeat. I only write down the new factors from my LCD. Now I go ahead and I go on to step 2, and I multiply every term by this LCD. So I multiply this first term by x plus 4x minus 3. I multiply this second term by x plus 4x minus 3, and this third term by x plus 4x minus 3. And what we should notice if we do this correctly, in this first term, the x minus 3's cancel, and we're going to be left with 2x times x plus 4. In the second term, the x plus 4's cancel, and we're going to be left with x plus 1 times x minus 3. And in the third term, the x minus 3's cancel, and we are going to be left with x minus 1 times x plus 4. All right, so the next steps just are cleaning everything up. So I multiply this portion out, and I get 2x squared plus 8x. I multiply these binomials out, and I get x squared minus 2x minus 3. I multiply these binomials out, and I get x squared plus 3x minus 4. Cleaning up that left side, and then we have to solve. So I notice I have a quadratic. I set everything equal to 0, and my first goal is to factor this, which I can factor, 2x plus 1 times x plus 1. If you needed to go through the product sum splitting the middle method, by all means do so. Now that we've factored it, we can set each of those equal to 0, and we get 2 answers, x equals -1/2 and x equals 1. Now the last step was to check our answers. This is pretty quick with rational equations. All I need to make sure is that my denominators will not equal 0, because remember the rules. when dividing by fractions or when dividing fractions, we can never divide by 0. So I need to make sure that -1/2 doesn't make any of my denominators 0, which it doesn't. And I also have to make sure -1 doesn't make any of my denominators 0. Again, it doesn't. So I can make my conclusion that those are my two answers. Lastly, we have radical equations. So the steps to solve radical equations are again very similar to the square root method for quadratics. Okay, we have to isolate one of the radicals if there are multiple. All right, we square each side of the equation, and if there's still a radical, we want to repeat steps 1 and 2. Then we go ahead and we solve, and of course check our solutions. Okay, so I'm going to quickly zoom in here, and what we should notice is our radical is already isolated. There's nothing happening out front, and there's nothing happening after the radical. So what we can do is we can go ahead and square both sides. Now it does help to put parentheses around everything just to verify. Okay, so when we do that, we square the radical. That means the radical cancels with that 2 there. We are left with 2x minus 3 on the left. Squaring 7 gets us to 49. Now we have a linear equation, which hopefully at this point is pretty easy to solve. When we do so, we get x equals 26. The last thing we need to do, though, is check our solutions. Again, I don't care if you do this in your head, but sometimes it does help to have the side note here, all right, and do it by hand. So I just quickly went through, I did it by hand, comparing the left side to the right side. I got both of those to be equal, so now I can go ahead and make my conclusion that x does equal 26. This last example, I'm going to leave that. That's kind of a bonus, a challenge question. I'm not going to worry about that right now. That might be something we address in class next time I see you. In the meantime, if you have any questions, make note of that on this note sheet that you have and bring those questions to class next time we see each other. Bye, guys.